These four rules you'll use quite a bit throughout every problem, so that's why I want to kind of address these first. So the first rule that we'll come across here for the derivatives is the constant rule. So this tells us that any constant value, its derivative is going to be 0. The constant multiplier rule, if we have a function or a power term multiplied by some constant value, that constant multiple stays in the derivative, and we take the derivative of the function of x that it's attached to. The power rule is a really important rule that we'll want to know, and that takes a function of the form x to the n power, where n is a constant value. This could be positive or negative. And we would take the derivative by multiplying by the exponent and subtracting the exponent by 1. So the derivative of x to the n becomes n times x minus 1, or n times x to the n minus 1. And then another rule that we can consider is the sum and difference rule. If we have individual terms that we're taking a derivative of, say an f function, a g function added or subtracted together, we can take their individual derivatives and then add or subtract them together. That would be the sum and difference rule. So let's consider kind of all of these rules will be kind of in this function here. We have the f function in part A is 4x squared plus 7x minus 3. So if I considered this to start out, my notation here would be, again, f prime of x as its derivative is equal to, I'm going to take it term by term, we have 4x squared. So the constant multiplier rule tells us that we can keep the constant multiple, 4, inside the derivative term. And then I'm going to take the derivative of the function of x. That would be take down the power, that's 2, and then raise x to the 2 minus 1. That would be the power rule, and then the constant multiplier rule. And I'll simplify this in just a little bit as we go through each term. If I take a look at the next term, I'm going to add, the constant multiple is 7, and the derivative of x itself is really, you could write it like this, 1x to the 0 power, because that's 1 minus 1. Now, usually we wouldn't write it like that. It would just be x to the 0, which is 1. So whenever we have a linear term like this, the derivative is simply just going to be that constant. And then the last term there, if we take the derivative of -3, well, that means we're taking the derivative, and the constant rule comes into play, and that's just going to be 0. So if I summarize this derivative and write it a little bit better, we have 4 times 2 is 8, x to the first power. And then the second term would just become plus 7. 1 times x to the 0 power is still 1. And so we'd have 7, and then 0 does not get to come along. So this derivative here would be just 8x plus 7. If we take a look at the next function, this is a g of x function. Let's go ahead and go term by term with this one as well. G prime of x would be the derivative name. We could keep the constant multiple in the first term as -7, and then the derivative of 4 to the x we would call 4x to the third power. We bring down the power and subtract 1 from the exponent. We've seen a linear term like this in the previous step, so the derivative of -6x would be just -6x to the 0. So that would be just -6, just going to be a constant. Now the last term we have is a little tricky because we have to work with this in the numerator. So if I need to get these powers in the numerator, one way I could rewrite this term is x to the negative second power. And we can still use the power rule with negative exponents. So let's apply the power rule here to x to the negative 2. That would be bring down my power, negative 2, raise x to the power minus 1. So that would be negative third power. So the derivative of 1 over x squared there would be 2x to the negative third. Now we can clean this up just a little bit. G prime of x is going to be negative 28 x cubed minus 6, and then minus, we'll have 2 divided by, we can put this back in the denominator as a positive power of x, so negative 2x cubed. And that would be our final derivative there. The next value we'll have is for c, h of x. This one looks like it has some different looking powers here with some fractions and square roots. So before I go, let me just rewrite this. We're going to want to find, again, h prime of x. And if I consider the square root of x in this first term, another way I could write that is 2x raised to the 1/2 power. And we'll want to convert those square roots or cube roots that we have as powers of x as rational exponents to be able to use the power rule. So let's apply the power rule in that first term. That constant multiple would be 2. We'd bring down the 1/2 and then raise x to the negative 1/2 because we're subtracting 1 from the power. So that's our first term. The second term, we have negative 4 is the constant multiple. We'll keep that. We'll bring down the power 2/3 and raise x to the 2/3 minus 1. That's negative 1/3. Now, the last term here, negative e, well, e as a value is just a constant number. So we want to be careful here. This is not e to the x like an exponential. This is simply just e. And so this value here is constant. So we want to treat it like a constant when we take the derivative. So its derivative there would be, if we wanted to write it, minus 0 or plus 0, regardless. It's going to be 0 either way. We'll take a look at exponential derivatives as well, and those will have a derivative other than 0, but this is just its constant base e. So that's just a constant value. So let's rewrite this one more time so it's nice and clean. We'd have 2 and 1/2 give me 1, and then the x to the negative 1/2 we could rewrite as a square root of x, but that would be in the denominator. So we can rewrite that as 1 times 1 over x squared, or 1 over the square root of x. And that's where we could leave it. We can do the second one, multiply our constant with 2, that would be 8/3. And then this would be a cube root in the denominator for x to the negative 1/3. So that would be 3, then cube roots of x. And since we don't have to add in that 0, we will be satisfied with that. We'll keep that as our derivative. In the next video, we will jump into a few more rules. We'll look at the product rule, quotient rule, and then we'll look at exponentials and logs as well. So thanks for watching. I look forward to seeing you in the next video.